Hello students, welcome to class 10. Since the school have been closed due to the coronavirus, so in order to keep the track of the studies, this is the first video which I have made of the chemistry portion, chapter 1, that is chemical bonding and equation. I've tried my best to give you every bit of the information of the topic. You have to go through the video thoroughly and then you have to read your books also. You have to make the notes by your own, and if there is any topic which you will be having problem with it, you can write down the queries, and once the school reopens, we can solve that. Along with that, you have to do your question and answers also. So the first topic is chemical bonding and equation.
Start with our first chapter of chemistry, that is chemical reactions and equations. Chemical reactions is the process of interactions of chemicals to form new substances. Now, what is chemical reaction basically in easy words? Chemical reaction is a simple combination of two different elements which combines together to give rise to a new different compound or a new different substance. In an easy words, we'll say that the process in which new substances with new properties are formed, or the process of interaction of chemicals to form new substances. As hydrogen reacts with oxygen to form water. Here, hydrogen and oxygen, these are two different elements. Two different elements have different properties, but the compound which is formed after the combination of hydrogen and oxygen is water, which has a new different properties from these previous elements. So, this whole process of formation of water from hydrogen and oxygen is called as chemical reaction. The other example would be magnesium combines with oxygen to form magnesium oxide. Now, magnesium is a metal and oxygen is a non-metal. Both the things combines together to form magnesium oxide. For this, there is an activity in the NCERT book, activity number 1.1. In that activity, there is a diagram also. You all have to go through the activity thoroughly. Many questions also comes in the examinations about this activity. Activity is, we will take some magnesium ribbon and we will rub the magnesium ribbon with the sandpaper. Here, why will we rub the magnesium ribbon with the sandpaper? First, I would explain you that what is magnesium ribbon. We all know that magnesium is a metal and metals can be beaten into sheets. So, we will be having a thin sheet kind of a ribbon of magnesium which is rolled. So, we will clean the magnesium ribbon with a sandpaper. Why do we need to clean the magnesium ribbon with the sandpaper? There is also a question like this. We need to rub the magnesium ribbon with the sandpaper because there is the formation of a basic layer of magnesium carbonate on it, which will not allow the magnesium to burn easily. So, before the experiment, we will rub the magnesium with the sandpaper so that the layer should be cleaned. Now, after cleaning, we'll burn the magnesium ribbon. Burning only takes place in the presence of oxygen. That is why I've written here magnesium reacts with oxygen, because we'll burn the magnesium in the presence of oxygen. So magnesium reacts with oxygen, it will form magnesium oxide. After this, we'll get magnesium oxide. So when we'll burn the magnesium ribbon, we'll see a white dazzling flame will arise. After that, we'll find some white powder. That white powder is magnesium oxide. It is a basic powder. Basic means when metals react with oxygen, they form metal oxides, which are basic in nature. If we'll dissolve it in water, it will be basic in nature. Okay, now the other topic is chemical equations. Now, what are the chemical equations? Chemical equations are the representation of the chemical symbols and formula. Like here I've written a chemical reaction, but I have written a chemical reaction in a word form. I've written full magnesium oxide. But instead of this, I can also write shortcut of this reaction, or I can use the formulas of these compounds and the elements. So the representation of the chemical symbols and formulas is called as chemical equations. Okay, now what is the benefit of this? What is the significance of this chemical reaction? Number one is that it is more informative. If we'll see here, we'll not get the idea of what is going through this. But if we'll write the chemical equation, it will be more easy for us, and it is also obviously less lengthy, because when we'll write, this is a small reaction, but in the chemistry we need to write a very long reactions. So it will save our time, it will save our paper, and at the same time it will be easy for us to understand. So that is why we write the chemical equation. So chemical equations are the simple version of these reactions in a symbol or in a formula manner. There is no difference between chemical reaction and equation. Both are quite same, but in chemical reaction we write the reaction, what mixes into what and what we get. But in chemical equation we write the shortcuts or the formulas of these reactions in an equation form. For example, here we'll write the same reaction above written, H2 plus O2 gives H2O. Okay, so hydrogen H2, oxygen O2, and water H2O. I have written H2 because you already know, you have learned in your class 9th about hydrogen and oxygen. Both are diatomic elements. That is why I have written H2 and O2. But this reaction is not balanced yet. This is a skeleton reaction. We will learn about the balancing the reaction in this video itself. The second example would be magnesium reacts with oxygen to form magnesium oxide. Now here magnesium reacts with oxygen to form magnesium oxide. This reaction is balanced. Magnesium is an element, oxygen again a diatomic gas, and we'll get magnesium oxide. This is balanced. I will tell you how to balance the chemical equations in this video itself. Chemical equations. Again, significance of chemical equations, it is more informative and it is less lengthy. Now, how to balance a chemical equation? We'll take the same example which I have given you. Magnesium plus oxygen combines with magnesium oxide. For this, we have to understand that in a chemical equation, there are two terms. That is reactants and products. The elements which we write in the left hand side are called as reactants, and the compound which we write in the right hand side are called as products. Those compounds or those elements which react with each other are called as reactants, and those compounds which are formed after the chemical reactions are called as the product. Now this is not a balanced reaction. Why do we need to balance the reaction? Because we have to fulfill the law of conservation of mass, okay, which is that the mass can be neither be created nor be destroyed in a chemical reaction. So we have to make sure that in a chemical reaction the total mass of the elements present in the product side will be equal to the mass present in the reactant side in a chemical reaction. So for that, like, we'll write a chemical reaction over here. Magnesium plus oxygen gives magnesium oxide. So we'll be writing here elements, reactants, and products. So product always have to be in the right hand side, and reactants always in the left hand side. So here we only have two elements, that is magnesium and the other is oxygen. Number of elements or number of atoms present in the reactant sides of magnesium is 1, and in the product side is also 1. Number of oxygen present in the reactant side is 2, but in the product side it is only 1. So what we'll do, we will write a 2 over here. But the number of oxygen also has increased by 2, so these are balanced. But here we have written 2, so it is into 2, it is 2. So we need to balance the number of atoms of magnesium in the reactant side as well, because again I'll repeat, the total mass of the elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactant side in a chemical reaction. So I'll write 2 also here. Now it is 2 mg, 2 mg, 2 mg, 2 here and 2 here. So this is a balanced reaction. I'll show you how. In a chemical reaction, we will have to make sure that the reactant side is always equal to the product side. So the balanced reaction would be 2 Mg plus O2 gives 2 MgO. Now we'll start with our next topic of the chapter is characteristics of chemical reactions. Now, when there is a chemical reaction, there are few characteristics. With the help of those characteristics, we are able to understand about the chemical reaction. Now, what are those characteristics? We will be learning about those characteristics here. So the first characteristic is the evolution of gas. Whenever there is a chemical reaction, there is any of these few characteristics which I am going to tell you today. So one of those characteristics which tell us that there is a chemical reaction going on, one of those characteristics is either a evolution of gas. So in a chemical reaction, there will be few things which we will get to know. With those things or with the help of those things, we will be able to tell that there is a chemical reaction taking place. So the first one is evolution of gas. For this, we will have to take some zinc granules in a conical flask. So here I have drawn a picture of a conical flask. So we will take some zinc granules. We all know what is zinc. Zinc is a metal, so we will take a zinc granules, some zinc granules in a conical flask which is transparent. I'll take you to the chemistry lab and then we'll do the experiment. It will be also in your book, so please go through your book as well. After this, we'll add some dilute sulfuric acid into the zinc granules. We'll see that there will be some bubbles of hydrogen gas. I have made an arrow in the upward direction. So these bubbles will tell us that there is a hydrogen gas which is evolved. So whenever there is an evolution of gas, maybe a hydrogen gas or a CO2 gas, any gas is formed, then that means that if there is an evolution of gas, that means there is a chemical reaction. So this is actually a exothermic reaction. I'll tell you about the exothermic and endothermic reaction. You already learned in your class 7th. If you remember about exothermic and endothermic, many of you would be recalling that. The reaction which produces heat is called as an exothermic reaction, and the reaction which involves or which requires heat to undergo the reaction is called as endothermic reaction. So but this is one is an exothermic reaction. So the one of the characteristics of chemical reaction is evolution of gas. The second characteristic is formation of precipitates. Now what is precipitates? I hope that you all of you remembering that what are PPT. PPT means precipitate. So precipitates are an insoluble portion or an insoluble part in any product form which is not soluble with this solution, it always settle down in the bottom of the beaker or any test tube, which does not dissolve with the solution. So that is called as a precipitate. So if there is a formation of precipitate, that is also that there is a chemical reaction taking place. For that example, we'll take some lead nitrate solution. No, lead nitrate is we'll take some lead nitrate solution, lead nitrate, and into it we will add some potassium iodide. We'll take some lead nitrate into a beaker, and into it we will add some potassium iodide. Now what we'll get? We will get a yellow color precipitate. Now yellow color precipitate, along with there will be formation of potassium nitrate. Okay, so we will take potassium iodide, that is potassium K, and iodine stand for I. So potassium iodide 2Ki will react with lead nitrate PbNO3. Okay, so with lead nitrate, there we will get this arrow which is in the downward direction means that we will get precipitates. Okay, so we will get precipitates of lead iodide. Okay, when potassium iodide reacts with lead nitrate, lead Pb and nitrate, if you will go through your class 9th science book, that is chapter number 4, you will find it that chapter number 3, there you are having some valencies of ions. You have learned those, so you would be seeing that NO3. So this is lead nitrate. Then we will get the precipitates of lead iodide, and along with we will get some potassium nitrate. Okay, so when there is a formation of precipitate, that means there is a chemical reaction going on. So again, when a colorless solution of lead nitrate reacts with potassium iodide, or when colorless solution of lead nitrate and potassium iodide are mixed, then we will get a yellow precipitate. We will get a yellow. Here also I will tell you that if there is a change in color also represents that there is a chemical reaction. If there is an evolution of gas, if there is a rise of temperature, if there is a formation of precipitate, if there is a change in color, it resembles the chemical reaction. So when colorless solution, this is an important one, please listen carefully. Colorless solution of lead nitrate react with potassium iodide, then we'll get a yellow precipitate of lead iodide. Okay, so after this we will tell you the next example. There was one example, and the other example, second example is when we will react barium chloride, or when we'll dissolve barium chloride into sulfuric acid, then again we will get precipitate of barium sulfate along with HCl. Okay, if we'll dissolve barium chloride with sulfuric acid, we will get barium sulfate. We'll get precipitate of barium sulfate along with HCl. So there is another example of formation of precipitate. Now, the formation of lead iodide can also be an example of change in color, but again there is another which I am telling you about the change in color. Okay, if we'll take potassium permanganate in a test tube, we'll take potassium permanganate which is purple in color. Potassium permanganate are crystals just like copper sulfate. Copper sulfates are blue in color, and potassium permanganate are purple in color. So if we'll take potassium permanganate and we'll dissolve it in water, and then into it we'll add few drops of lemon juice, what we'll get? We'll get a colorless solution of potassium permanganate. The color will fade. So the purple color will fade into colorless. So if there is a change in color, that means it is a chemical reaction. Now the another example of this is when potassium dichromate. I think you will not be able to see properly, but just have a look on this. Potassium dichromate solution is orange in color. I was trying to make an orange color, but I wasn't having it. So when potassium dichromate, that is orange in color, when will pass SO2 gas, that is sulfur dioxide gas, then that will form into green color. So the orange color of potassium dichromate solution will change into green color if sulfur dioxide gas is passed through it. So it will change into green color. The next one is change in temperature. Again, when there is a change in temperature, again there is a chemical reaction. So if we'll take simple calcium oxide. Now calcium oxide is also called as quicklime. CaO is also called as quicklime. So when we will add water into calcium oxide, okay, I'll tell you a simple activity. If we will take powder of calcium oxide into a beaker, into it we have to take a hard glass beaker, because it's a very exothermic reaction which produces a lot of heat, and this is the change in temperature. Into it we'll add some water. If we'll touch the beaker, we'll find the beaker is hot because it forms a rise in temperature. A lot of heat is evolved in this process or in this reaction. Along with that, calcium hydroxide is formed, that is CaOH whole twice, that is CaO plus H2O. CaO is calcium oxide. CaO plus H2O, when it reacts with CaO reacts with water, it gives CaOH whole twice, that is calcium hydroxide, and a lot of heat is evolved in the process. So it is a change in temperature. Then the last one is change in state. Told you previously about when we will burn magnesium ribbon, we will get a powder white substance. That is, the magnesium ribbon is converted into a powder state. So if there is a change in state, it also tells us that it is a chemical reaction. So the important characteristics of chemical reactions are evolution of gas, formation of precipitate, change in color, change in temperature, or change in state. All these characteristics tell us about the chemical reaction.
Hope you are clear with the topics told you today, so you can write the notes and make the assignments of the topics which have been covered today in the video. Along with this, you will also go through the activity number 1 from your textbook NCERT. This is 1.1 activity about magnesium ribbon. Along with this activity, you will also read activity number 1.2 and 1.3. After this, we have covered chemical equations and balancing the equations. So you will be solving these 3 questions as your homework for today. If you have any problem in solving the questions, I will be helping you out with these questions in the next video. Next topic we will be starting tomorrow in the next video. And along with these questions, you also have to write 5 questions of the balancing equation. This balancing equation I will be taking again, as I think it will few of the students will be having problem with the balancing equation because it's difficult for few students. So I will be telling you again, but for now I want to check that whether you have understood or not. So these 5 questions you will be solving as an assignment. That is, number 1, hydrogen reacts with nitrogen, gives ammonia. So you have to balance this first equation. And then the second equation is Na plus H2O. Na is sodium plus water gives NaOH, that is sodium hydroxide plus hydrogen. The third question is hydrogen plus chlorine gives HCl, that is hydrochloric acid. Then iron plus water gives Fe3O4 plus hydrogen. And at the last is zinc plus H2SO4 gives ZnSO4 plus H2. You have to do these questions along with the questions from the NCERT book. and I will be discussing the questions and the answers of these questions in the next video. Thank you.